Number 80, integrated concepts, letter A. Show that the period of the circular orbit of a charged particle moving perpendicularly to a uniform magnetic field is this. All right, so you got to remember the period of a circular moving object. This goes way back to circular motion, and that the period is going to be equal to 2 pi r divided by the velocity. Oops. By the velocity of that moving particle, okay? And that's the tangential velocity. So now what we're trying to do is we're trying to show how now this formula is the period for an object moving through a magnetic field, okay? So in other words, the formula that kind of relates the two is going to be this one over here on the right-hand side. This says that the radius of curvature is equal to the mass of the particle multiplied by its tangential velocity divided by the charge, multiplied then by the magnetic field. So the relationship now between these two is simply going to now be a simple plug-in. If this is the radius of curvature and this represents the radius of curvature, then I can just substitute this on in for r. So this is now going to work out to 2 pi multiplied by the mass times the velocity divided by q times the magnetic field, strength divided by then the velocity. So if we notice the velocity cancels, okay, and what we're left with then is we are left with then 2 pi times the mass all divided by qb. And that's exactly what this formula says over here. So that's letter A. Let's move this on over to deal with letter B. Okay, so B. It says, what is the frequency? So you have to remember that frequency is just simply going to be 1 over the period. Okay, so frequency here is just going to be the inverse of this thing down there. So it's now just QB all over 2 pi m. If only all the problems were like that. So that's letter B. Letter C now. It says, what is the angular velocity omega? So we have to remember that the angular velocity here, omega, is equal to 2 pi multiplied by the frequency. Again, this all comes way back from circular motion. So check out that chapter if you need a little review. So this is then the angular velocity is equal to the 2 pi, then multiplied by the frequency here, which is going to be qb divided by 2 pi times the mass. See you later, 2 pi. qb all over then m. And that's then the angular velocity. And note that these results, cool. And that's it. All right, guys, thanks so much for tuning in. Appreciate it. Please remember to help us out and subscribe, and I'll see you soon. Take care.